Hi everyone, welcome back to week 3 discussion in Chem 330. So in the previous video I talked to you all about hybridization, right? If given a compound, can you tell what kind of carbons do you have in your compound? And I walked you through if a compound entirely contains single and double bonds, then most likely your compound is planar. If your compound contains at least two single and a double or all single bonds, it will be all sp3 hybridized. And if your compound contains alternate single and triple bonds, then your compound is linear, right? With that said, the material I'm going to walk you through is pretty generalized this time. Okay, this is not any particular concept, but this is something I think you will need to know if you're preparing for any pre-professional exams, or even if you're if you have a doubt and if you didn't understand something I said and you're going to go look up help elsewhere, then most likely you will not see this kind of writing. Okay, let's say if this is the compound, okay, that you have some confusion over, or something related to this compound, something like this. Okay, if this is the case, okay, and say you're going to go get help, what you will see is, now this type of skeletal structure is mostly common only when you're learning how to name a compound, whether it be alkane, alkenes, or alkynes, but it's purely written in this skeletal form when you're learning to name a compound. But what you will see textbooks do, or other online resources, they will not do this because it's difficult. It takes time to construct one of these on a ChemDraw or other softwares. So what instead you will see is line structures. Okay, you will not see these general skeleton structures, which is completely expanded. What you would see is skeletal structures. Okay, let me go get a different color. Okay, all right, so how can we transform this molecule into a line structure, or given a line structure, how can we get this back? Okay, you don't need to get this back, but you need to know that you have the right line structure. Okay, and for some of the remainder of the course I would also be using line structures because it's condensed, it's not as big, and over a course of time we can be using this because again this is not how you will be tested if you're going outside of my class. So we've seen enough of these kind of compounds while we learn how to name alkanes, alkenes, and alkynes, but I think it's time we step up the game. Right now, you don't need to really focus on if it's a long chain, short chain. None of that is so much of a concern if you're going to just draw your line structure. Okay, typically in a line structure we draw a simple one, not necessarily related to this compound above. This is a compound. This is a compound on its own. Let me erase it and draw it clean. Okay, so say this is the compound. Okay, you think really that's not, yes, it is a compound. All right, the ends, okay, whenever you have a line structure, the end is a carbon. Okay, this end is also a carbon. This is also where it bends is also a carbon. Okay, keep that in mind. Students think that the ends have nothing. It's only what's inside the ends what matters. No, everything matters here. All right, so let me redraw this. Okay, now let me get a different color so I can show you exactly where they get confused. Okay, when it ends, what that really significance is, it's a CH3. Okay, and whenever you have a bend, that's a CH2. There is no exceptions to this rule. Okay, unless you see something coming off it, which we will see. Whenever you have a bend, that's a CH2. Okay, again, whenever it's a loose end, it's a CH3. Why do I emphasize this of all the things that's important? Because if you don't understand this, your view of how you're going to carry out reactions and something you would learn in the future, and an important concept called stereochemistry. Okay, we can be always writing this expanded skeletal structure that you see here. Okay, that takes time, and you know it's too broad for longer molecules. We can't be doing this. Okay, it just becomes too big. We want something more condensed. Okay, so this is the structure we will start to use, and it's very important you understand it. All right, so let's go get, so keep in mind, so if this is exactly the molecule, so if you go back and write this, it would be CH3, CH2, CH3. This is the molecule. Okay, it's easy to go from here to here, it's only difficult to go from here to here. Okay, this is easy. This is difficult for students, and so that's what we're going to focus on this video. Practice a few compounds. You just have to know a couple, so you can always know what you're dealing with. All right, so let's go get another compound. Okay, it's simple. If you know this, you got it. Okay, now again, if you're still lost, always go first. If you want to name this compound, okay, first you got to go put carbons everywhere. Okay, and again you have to look for the longest chain, right? So this is 3, right, 4, 6 carbons, right? Now what if I had gone this way? Okay, that would be 6 as well. If I had gone this way, that would be 6 as well. So it doesn't really benefit. I'm just going to leave it here. And I have a carbon here, here, and here. So I have a total of 3, 6, and 9 carbons. But my longest chain is only 6 carbons, right? And we know 6 carbon is hexane, right? Because you don't see any double bonds. So it is an alkane, right? It is not an alkyne either because there is no triple bond, right? Now, that means these are your substituents, right? Let's go get the orange. Okay, that means this whole thing is your substituent. Okay, this is the bond that connects this substituent, right, to this carbon, and this is a substituent which connects it to this carbon, right? And as I said, every end, wherever it is, if you see an end and it's not going any further, that had to be a CH3. Okay, so let's go get our blue again and redraw this whole thing, but this time we are actually going to put things in it. Okay, right, this is what I had, right? Let me go get my red again. Okay, if you see, ends are always CH3, so go ahead and put CH3 here. Okay, now this seems to some of you who got it right away as soon as you saw me explain it, that means you are the ones that have no problems with it. But if you're watching the video second, third time, more likely you will struggle if this were to be the case. And if it's not taught or if it's quickly brushed, more likely this would lead more difficulties for you. Okay, so we have a carbon here. And then, as I said, this is a bend, so it's got to be CH2. Not all bends are CH2, okay? Be careful. I did explain it. If there's nothing sticking out of the bend, it's a CH2. Okay, now if you notice here, this is also a carbon, right? They're all carbons, right? Now, this carbon is attached to a CH3 on one side, it's attached to a CH2 on the other side. Now, this is just the bond, okay? There's nothing here. It's just vacant, there's bond. And this is attached to a CH3. So, this carbon technically has 3 bonds. So, the 4 has to be an hydrogen, okay? So, if you have a bend, that is CH2. Whereas if you have a bend and something sticking out of it, just one stick, then that's a CH, okay? Now, if there's two sticking, then that carbon has no hydrogen. That's why if you watched I believe my last video in week 2, okay, I did walk over how to tell if a carbon is primary, secondary, tertiary, or quaternary. If you have not watched that video, go back, watch it. Okay, again, same deal here. This carbon, okay, is at the bend, but as I said, it's not always CH2, okay. This carbon is attached to CH3, 1, 2, 3 bonds, so this carbon is attached to a hydrogen. This is also the same deal. Not every bend is a CH2 because this right here, carbon is attached to 1, 2, 3, right? 1, 2, 3 bonds, right? So that means this carbon also has a hydrogen, right? Same thing, there's nothing sticking out of it, and that's it. So if we go back and draw this entire compound out, this is what, you don't need to write it a straight chain, you can just write it the way it looks like. So it's CH3, CH, CH3, so CH2, CH, CH, CH3, CH3, CH2, and CH3, right? Now we do know our carbon, I'm going to write the name here, sorry about that, the screen does look a little crowded now, but again, if you're watching it as a video, not all of it would appear at the same time. You would appear like in a PowerPoint presentation, one animation at a time, right? So let's go get the name. Okay, so we have a methyl. This right here is a methyl substituent. And if you all remember, this is the one thing I had you write down. This is an isopropyl group, the whole thing, right? This whole thing is an isopropyl group, right? So what's the name of it? So it'll be, you have to pick the side that kind of leans. I'm going to guess that where do we start numbering from? 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6? Well, if you think about it, this side also has a substituent, this also has a substituent, right? This side has only one carbon, and this side we have 2, so we start numbering from here. So it'll be 1, 2, 3, 4, 5, 6, right? So what's the name? Well, one is isopropyl, the other is methyl. Methyl comes EFGHIJKLM, right? So M comes after I, so it'll be 4 isopropyl, right? 2 methyl, and we have 6 carbon, so it's hexane, right? This is a good opportunity for you to, recoup your learning of the naming one more time. But again, I'm not doing this particular video to teach you naming, but it's more about transforming a full skeletal structure into a condensed aligned structure, all right? So let's get rid of this and just practice one more compound, okay? And I have you, this is how you will see most of my future homeworks to be as well, on quizzes and anything else in between. Again, if you're struggling initially, you would do exactly what I did. All right, so let me walk you through this entire compound, okay? Now again, you can use different colors if you want. That will be a good place to start. As I said, every carbon that's loosely hanging and it's not connected to any other carbon in the entire molecule is a CH3. So we have a CH3 here. We have a CH3 here. CH3, 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 and CH3. Okay, these are the loose ends. We got them labeled as CH3. Now let's go get bends that don't have any bonds sticking out of it, and there's only 2. All right, so this is a CH2, this is a CH2. All right, now if I said you have a bend but there's only one bond sticking out of it, then we know right away Well, in all these cases, this is a CH, this is a CH, this right here is a CH, right? Same here, this is looking like a bend and a bond is coming out of it, so this must be a CH. This is nothing coming out of it, it's just a bend, so this is a CH2. What have I missed? Okay, that is a CH2. See how simple that is? We just need to know that. Now let's go put everybody together. So this time I'm going to draw the molecule in maybe black, and then I will connect the substituents. I'll draw the substituents in so you have your CH3. Okay. Oh, actually, that's not what I meant to do, but I guess it's just practice, you know. We're all addicted to our practices and habits, so okay, no matter where we go, we're addicted to our practices. Because I'm so used to writing the line structures, I automatically start drawing it without beats the purpose of what I was trying to do. Okay. This is what I was really trying to show you. You can do this way if you want, but that's only, you can only do so much. I mean, how many if I give you 15, you're not going to be able to do it for all of them. So just get the idea. Okay. All right, we got our straight chain. I'm going to guess that's probably, this is our longest chain. Well, 1 2 3 4 5 6 7. If I go this way, right, 1 2 3 4 5 6 7 8, right? Whereas if I had gone here, it would have been 7, right? So my longest chain actually is this. So CH2, CH3. That's why I'm drawing it in black. Again, just because we're going to a different area in chemistry doesn't mean the rules change. Rules are not flexible. Rules are rules, right? Keep in mind, if I had gone 1 2 3 4 5 6 7, right? That's 7 carbons. Whereas if I had gone this route, I would have got 8. So that is my longest chain, and this becomes my substituent. You see why I'm using different colors? If I do it all in one color, it's going to be just really confusing. So which is why we are doing it this way. Keep in mind, most of the professional exams you will probably take would have. Now obviously this cannot ever be straight chains, so I'm just going to put these in blue as well, because there are substituents in half of it. So don't forget, in the process of doing this, don't forget that the rules don't change. Okay, that's it. So these are my 3 substituents. You would have thought that this was part of the chain and this was substituent. No, you still have to go look for the longest chain. And when I do, I get 8, whereas this way I'm getting only 7. You can do just the way I'm doing, you'll be fine. All right. So where do I start numbering from? Well, this is where I encounter a substituent, and as I said, this is also where I encounter a substituent. But visually looking at it, right? Visually looking at it, which side do you think, if say this is my CISA, there's 2 ways, I've explained you 2 ways to do this, right? If this is somewhere, right, this is the 4th carbon, right? If you put the CISA, maybe even here, it doesn't matter. Let's do that. Some of you might think, oh, it's not really a perfect CISA. Well, let's do this. Let's say you put the CISA here between 4 and 5 because we have 8 carbons. Which side do you think visually looks big? Or which side do you think a person sitting, it's like a child versus a man sitting on a CISA? Well, you see that this side is pretty heavily crowded than the side, right? So we're going to start numbering from this side. Let me go get my red again. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So what does that mean? This is an isopropyl group. The whole thing is, okay? This whole thing is isopropyl, right? This right here is a methyl. This right here is an ethyl. You got it. See, that's why I taught you, everything we're learning is scaffolded. I am not going to teach you something that is so offbeat that you have no prior knowledge about it. Everything I'm teaching you is slowly built on something previously. By the time we get to reactions, you should not have these foundational issues. Okay, because if you're planning on doing organic 2 with me or with another professor, you don't want these foundational knowledges. Okay, the professor, if you're with me, then I know where your strengths and weaknesses are, but if you don't, then you have to know the foundations correctly. These will not be taught to you in organic 2. The professor would start directly with reactions in line structures, and if you don't understand that, most likely you're going to be so lost. All right, so let's go back and write the name of this compound. With that said, we got 2, 3, and 6 is where the substituents are, so we know the locations of our substituents. They're all different. This is methyl, this is ethyl, and this is isopropyl. I think E comes first on the list of alphabets, so it would be 2 ethyl, 3 isopropyl, 6 methyl. How many carbons did we say? 8 carbon is octane. So octane. Does that make sense? All right, let me give you a few more compounds to practice, and then when I see you in class, I will provide solutions to it, and then I'll make a video for that solution to that problem. All right, but not right now, but I want you to try it. Okay, now the same logic extends to alkenes and alkynes as well. So in my practice, I'm going to give you a bunch of problems, at least 3 or 4 problems. Each one would target, a different area of the alkane, of the carbon family that we have learned. So it's A, that's your first compound. Second compound is do these compounds exist? Probably not. But again, people might need to make these compounds. Maybe if they did, maybe they will make it. Okay. All right, so 1 from each category that we have learned. There we go. So in all these cases, identify the substituents, identify the longest chain, and name the compound. All right, if possible. All right, okay, so here's what I want you to do. Okay, transform line to a full skeleton structure. Okay, line to a full structure. That's easy. I mean, I've already given you this. And then identify the longest chain. Now, I won't be doing this on the test, right? So you should know that you should always identify the longest chain. Okay, and then name the compound. Okay, so that's what you're going to do for all three of these practice problems. All right, so that concludes that video, and stay tuned for more Chem 330 videos.